This is Euclid Book 10, proposition number 61. Yes, we're going to be using the same diagram for the next 4 or 5 proofs. So hang on. The square on the first bimedial straight line applied to the rational straight line produces as breadth the second binomial. Let AB be a first bimedial straight line divided into its medials at C, of which medials AC is the greater. Okay, so we got line AB across here, and it's going to be a first bimedial straight line. It's divided into its medials at C, and AC is the greater length. Let a rational straight line DE be set out. That's this one right here. And let there be applied to DE the parallelogram DF. Well, that's this whole parallelogram right across here. And the area inside of this whole parallelogram is going to be equal to the area of the square on AB. Now, you say, wait a minute, what square on AB? We took line AB and we made it into a square, and all 4 sides of that square are going to be the length of AB. So this whole area is equal to that. Now, we're going to produce DG as the breadth of the entire DF. Okay. I say that DG is the second binomial straight line. So let the same construction as before be made. Okay. Then, since AB is the first bimedial divided at C, AB, first bimedial divided by C, therefore AC, CB are medial straight lines commensurable in square only. These here are medial straight lines, and they're only commensurable in their square. Okay, the lines aren't commensurable, but the squares are. And they contain a rational rectangle. This is by Euclid Book 10, proposition number 37. So that the squares on AC and CB are also medial. Okay? This establishes that these 2 squares are medial. This is by Euclid Book 10, proposition number 21. Therefore, DL is medial. Okay. This whole rectangle right here, this and this combined, that's DL. Okay? It's medial. And it has been applied to the rational straight line DE. This whole rectangle has been applied to this. Therefore, DM, this line across here, is rational and incommensurable in length with DE. This line is rational and it's incommensurable in length with DE. This is by Euclid Book 10, proposition number 22. Again, since twice the rectangle ACCB, okay, that would be this one right here, is rational, MF is also rational. This whole rectangle right here is rational. And it has been applied to the rational straight line ML. Okay, so this whole rectangle has been applied to this. Therefore, MG, this whole line across here, is also rational and commensurable in length with ML. So this line is rational and it's commensurable with this length. Now, this length also happens to be this length. That's by Euclid Book 10, proposition number 20. Therefore, DM, this line right across here, is incommensurable in length with MG. So this line is incommensurable with this line. That's by Euclid Book 10, proposition number 13. And they are rational. Therefore, DM and MG, okay, that's this line right here and this line right here, are rational straight lines commensurable in square only. Therefore, DG, this whole length right across here, is binomial by Euclid Book 10, proposition number 36. It is next to be proved that it is also a second binomial straight line. For since the squares on ACCB, that's these right here, are greater than twice the rectangle ACCB. So, here's how this works. You take this rectangle right here, you take its area, you multiply it by 2. If you add these 2 areas together, they'll be greater than twice that area there. That's how that one works. Therefore, DL is also greater than MF. This whole rectangle here is greater than this whole rectangle right here. So that DM is also greater than MG. This length right here is greater than this one. This is by Euclid Book 6, proposition number 1. And since the square on AC, that's this one right here, is also commensurable with the square on CB, that's this one right here. These two are commensurable. DH is also commensurable with KL. These two areas are commensurable. So that DK is also commensurable with KM. So this line and this line are commensurable. This is by Euclid Book 6, proposition number 1, and Euclid Book 10, proposition number 2. And the rectangle, DKKM. Okay. So, there's that rectangle right there. Is equal to the square on MN. Now, where's the square on MN? You take line MN, you draw a square out of it. This area is going to be the same as that area up there. Therefore, the square on DM. Okay, so if we take the line DM, we make it into a square. That square there is greater than the square on MG. Now, if we take that whole line right here and we make it into a square, then the area in that square is going to be bigger than the area in that square. By the square on a straight line commensurable with DM, which would be the square on this side. If we take DE and we make a square out of it, that's what it's saying. This is by Euclid Book 10, proposition number 17. And MG is commensurable in length with DE. Okay. This length is commensurable with this. Therefore, DG is a second binomial straight line. This is by Euclid Book 10, the second set of definitions, number 2. And that is the whole proof. I will tell you more in a future video. Stay tuned.